Yeah, hello guys. Welcome to Network Tips. So we are still in the network fundamentals. Today we'll be looking at the OSI model and the TCPIP model, understanding each and every layers in the OSI model and the what applications and the what applications and data and what functions on each layer. So the OSI model is basically a set of standard, more like a blueprint that allows and a blueprint that allows these network devices to communicate with one another. Back in the days when IBM ruled the world, they have to come up with their own model and and standard that just only IBM system can communicate with one another. But but and okay, Dell will now come up with their own blueprint, their own set of model, and it's only Dell system can communicate with one another. And you find out that now, if you have a Dell system and you have IBM system in the same environment, you find out that these two devices cannot communicate with one another. So this issue went on, and these guys, ISO decided to come in and they intervene, and they now brought out the OSI model, this guy, and I think around 1984 or so. So this OSI model now serves as a guideline, a blueprint for developers who wants to create applications and applications that run over the network. It also enables these network devices that speaks different languages and that speak different languages to communicate with one another as well. It also enables to know how data is being sent across and being received on the network properly. So having said that, let's see the OSI model. So the OSI model is basically just this 7-layer data model. It starts from here, number 7, they have the 6, they have the 5, they have the 4, they have the 3, 2, and the 1. So these guys are these are the 7-layer model. Let's start to meet each and every one of these layers, starting from the layer 7. So on this layer 7, we have applications, more like your, let me say, your browsers, your browsers which will be running, which depends on HTTP. They'll be running on HTTP applications. They are all HTTP application. For the secure one is HTTPS. We also have applications like FTP, which is for file transfer. We also have Telnet, which is for remote connection to a device, a terminal remote connection to a device. The secure one, which is SSH. So these are set of applications that will be operating on this layer model. These are applications that are all aware of network on your device. They will all reside on this application layer. Then what this presentation layer does is that it translates, it encrypts and decrypts data. Then the section layer initiates section between these devices and terminates the section as well. Then the transport layer is where UDP and TCP, we have two types of transport protocols. We have UDP and TCP. I mean to say, so this where these transport layers, this transport protocol reside on the UDP and the TCP, and there are different port numbers as well. So depending on the application that you are running, HTTP, PPOE, FTP, depending, that will determine which transport protocol that it is is going to use. Then the network layer, the router reside on this layer. This where the source and the destination IP address will be determined. Then the data link layer, is where the switch reside on. This where the source MAC address and the destination MAC address also be reside on, and also something that they call cyclic redundancy check for checking errors, for checking the integrity of the data as well. This where it will reside. Then the physical layer, is where the cables, the voltage, the media, the connectors, all the bits, the zeros and one. This is where it's going to reside on. So as a network engineers, we also use these layers for troubleshooting. So you should have these layers at heart. So regardless you are going to write the exams, you should have it at heart. You are going to make use of these layers for all the days of your life. So you're going to, when you have an issue, oh, this issue occurred, is it a layer 1 problem, is it a layer 2 problem, is it a layer 3 problem, is it a layer 4 problem, depending on what occurs, this layer is going to guide you to determine how you're going to troubleshoot the network as well. Maybe for example, the user is having an IP address but is not able to go out of the internet. You know that, oh, this is where it's residing, the router. Or maybe the user is not able to, or the two devices is not able to communicate with one another and they are on the same network. Then this is where it's residing. This issue can also be, oh, the user is on the same network but is not able to communicate out to the internet or to the device that is on the same network with. This might also be a physical layer. So if the cable is not properly connected, then there is no way you can also communicate. This might also be that, okay, the user can reach the internet, but it cannot reach some specific sites. So this will also reside on maybe the application layer as well. So these are the way you as a guide to use these stuff to troubleshoot. So as a network engineer, mostly it's from the layer 1 to the layer 4 that we are mostly interested in, but time will go on where you also have to look into the 7, 5 and 6 layers as well. Then let me give you a real life scenarios on how packet is being transmitted over a network. Let me say I have a user here. This user, let me call, I have Ebuka here. His name is Ebuka. Then Ebuka wants to make a bank transfer, a bank transaction to his bank. Let me say his bank is Kuda. He's making use of Kuda, and he wants to make a bank transaction. Yeah, his transaction, of course, this bank transaction that he wants to make use of is going to pass through these several layers: the application layer, the presentation layer, the section layer, the transport layer, the network layer. It's going to pass the the network transport layer is going to pass the data link layer and also the physical link layer. The same way on this server end is going to have the application, the presentation, the section, the transport, the network, the data link layer, and also the physical link layer. So let me say Ebuka wants to make this bank transaction. Of course, he's going to use his mobile app or he's going to use the web, and you know that this web runs on, whether the web or using the bank app is going to run on HTTP of course with the S, because this is a very sensitive data he's trying to send across the network, so the data should be encrypted. So once he send his packets across this layer, is going to this HTTPS is going to be residing on this application, this data. Then this data is going to, once this data comes down to this presentation layer, the presentation layer is going to encrypt this data. So the presentation layer, the data is going to come down to this section layer. The section layer is going to initiate connection. This is going to initiate this section to start running. Then this, from here to here, this is still known as data. So once your packet leaves this section layer and comes down to this transport layer, this transport layer is going to break it down to what they call segments. Going to break it down into small segments. So this small segments is going to add its header. It's going to add which transport protocol is going to be running, which of course this is a sensitive data, so we want, it's going to be a reliable connection. So it's going to make use of TCP transport protocol. Don't worry about if you don't know what TCP transport protocol is now. We're going to review it in the next lecture. Then it's going to add its port number. Of course, the HTTP port number is going to be 443, the port number for HTTPS. So it's going to add it on each and every one of these segments and send it to this network layer. This network layer is going to convert this segment to, it's no longer going to regard it as segment, it's going to be known as packets now. So this network layer is going to, of course, add his header as well, attach each header on these packets with the header of the transport protocol being there as well. It's going to add the source and also the destination IP on these packets as well, to determine, so what this network layer is doing to determine where to forward these packets to. So immediately it leaves this network layer and comes down to this data link layer. The data link layer is going to convert it to, it's going to convert these packets now to what they call frames. These frames now have your source and destination MAC address, and you also have what they call CRC check on it to check the data integrity of that frame. So what this check does, that it detects this error. If there is any error in this frame, it does not correct that error, rather it will flag it and indicate to the end device, the receiving end device, that this data is not is corrupted. So it does not corrupt the error. So once this data comes down to this physical layer, it will change to zeros and one to go through your cables and your connectors, and it will enter to this other one. So this other one receiving this data now will now this 0 and 1 will now send it back to this data link layer. Data link layer will of course remove his own header. The same thing will happen on this network layer. This network layer remove its own header. So the same thing is going to happen, come down to this transport layer. This transport layer will remove this header. The same process that it passed through while sending, that same process is going to pass through while it's receiving, but rather it will be the reverse process of it. So once it gets to this transport layer is going to wait until every other segment is received before it will now send it back to this guy, the the upper layer, the section will terminate it, send it to this one will decrypt it, send it to this one will receive it, and send it to your guy, send it to the server, the transaction will be processed. So I don't know if any of you have captured data on a Wireshark before. You notice that it's just being break. It's not going to be a one full data. So that's how it is. Even your web page, once you are sending your web page, you see the pictures, it's transmitting on its own. Your click, your send icon, your send icon will go its own. The power icon will go its own. Those things, the data is not transmitted at a go. So you only see that data once everything is being formed on this transport layer, and now send it back to you and see it as in a very fine GUI form, and you're just, oh, that's it. So that's basically what is happening on the background. So as we as network engineers need to understand this process very well. It's very important to know that, to understand how this process is being going on the background. Oh my, this thing looks so messy. So then the TCPIP model. The TCPIP model is basically the stripped down version of the OSI model. It's very important to note that this OSI model is no longer in use anymore. So what we are currently using now is the TCPIP model, but it's very important to understand the OSI model, and very easy for you to understand the OSI model, then link it to this TCPIP model. So you can see on the OSI model, you can see your application, your presentation, your section. They all reside on this application layer on your TCPIP model. Your transport is still your transport. Everything that is still happening on these layers on the OSI model is still happening on this on the TCPIP model layers as well. Then your network is now considered as your internet. Then your data link layer and your physical link layer will now reside on the network access layers. Now you can know these layers by heart using these mnemonics, like the TCPIP model. You can use the 18. So remember this. Why the OSI model? You can use this. All people seems to need data processing as to remember it. So with this, this video will come to an end now. I would like to thank you for watching. See you in the next video.